Hey guys, this is Mr. Grice for Algebra 1, Chapter 11.3 Notes. Today we're talking about adding, subtracting, and multiplying radicals. And remember, radicals, another word for that is roots. So before we get started, there's a couple things that we need to do. I wrote a note on the top of it that says, write the perfect squares, okay? So right where that's going, I'm going to start writing the perfect squares. We got 1, 4, 9, 16, 25. You guys should start to know these numbers by heart now. And this list keeps on going, okay? So our learning target today is to be able to add, subtract, and multiply monomials and binomials that contain radicals. So quick side note right here, that we are allowed to add and subtract like terms. So if we add 3x plus 5x, okay, we would add the coefficients, and then the x would stay the same. Okay, now we can do the same exact thing with radicals. Okay, we would combine the coefficients and the square root would stay the same. Okay, and that's what we're going to be doing with the first set of the notes. Okay, our rule says you can add or subtract the coefficients of like radicals as long as it's the same number in the root. Okay, so for example number 1, those are the same, which means these are like terms. So we would combine the 2 and the negative 5. When you do that, you would get negative 3 root 3. Okay, now for number 2, are these the same or are they different? Well, they look different to me, so if they're different, we can't combine them. Okay, so the way we would write that would be 2 root 3 just minus 5 root 2, because we can't combine them. Or the other way that you would see it written would be negative 5 root 2 plus 2 root 3. Okay, and the reason why is because we write the roots in order from the lowest to the greatest. Okay, all right, example number 3. Are they the same or are they different? Well, they're the same. Okay, so we have to add them. Negative 6 plus 8 gives me 2 root 2. All right, number 4. Now, right off the bat, you'd be like, those aren't the same. We can't do anything to them. Well, we can actually break both of those down. Okay, this breaks down to 4 and 3. Square root of 4 is 2 root 3. Okay, we're not going to be showing you how to break this down anymore. If you need to remember how to do that, you need to watch 11.1 or 11.2 notes. Okay, now 48 breaks down to the square root of 16 and the square root of 3, which is 4 root 3. And now you can see that we've got like terms, and we can combine them together to get 6 root 3. All right, example number 5. Can we break any of these down? And the answer is yes, okay? We can break down the negative 45 and we can break down the 75. So, I'm just going to write the square root of 5 because nothing changed from that. 45 breaks down to 9 and 5 plus 3, and it goes to 25 and 3. So the root 5 stays the same, minus 3 root 5 plus 3 times 5 root 3. And then 3 times 5 is 15. And now when we look at it, everything is the same. So we can combine everything, or not everything. The only thing that we can combine, I'm sorry, are these guys. And remember that this has a 1 in front of it, so it's 1 minus 3. Well, 1 minus 3 is negative 2 root 5 plus 15 root 3. Alright, and now if we wanted to write that in order, it would be positive 15 root 3 minus 2 root 5. Okay, I'm just going to move those so I actually have room to do the next problem. Alright, number 6. Okay, I can't break down 3 root 6, but I can break down the square root of 54 to 9 and 6. So that changes to 4 times 3. 3 root 6 is the same, and 4 times 3 is 12. Now, are they the same? Yep. So I'm going to add the coefficients, and then we're left with 15 root 6. Okay. All right. Now let's move down to this, multiplying radicals. When we're multiplying radicals, we need to multiply the coefficients with the coefficients and the radical with the radical. That's what we've been saying, the inside with the inside and the outside with the outside. So when we multiply, if we have a monomial times a binomial, how do we do that? Well, we distribute, and we would get 3x squared plus 4x. So we are multiplying that. Okay? And that's what we're going to do with the first two problems. So I'm going to zoom in so we can just look at those. So, alright, so we have the square root of 3 times 5. Well, what does that give us? Remember that the coefficient comes out front, and then the square root. Okay? And now we're going to do root 3 times negative 1 root 3. So, and we have talked about that. When you multiply those, it turns into 3 because that is the square root of 9, and the square root of 9 is 3, so we're skipping that middle step. But if one of them is negative, it would be negative 3. Okay? So this is where we get negative 1 root 3. Or not root 3, I'm sorry. Would be negative 3. Okay? So we're left with 5 root 3 minus 3. Okay? And can we combine those? No, we can't, because take a look. They are not like terms. So if they're not like terms, we can't combine them. It would stay like that. So our answer is just like that. Okay? All right. Example number 8. So we are going to distribute. So we have root 5 times 6 root 10. So inside with inside, outside with outside, there's a 1 out here, so 1 times 6 is 6. And 5 times 10 is 50. So we get 6 root 50. And then the other one, we have root 5 times 1. And that's going to give us just root 5. And we have 1 root 5, but we really don't need the 1. So plus root 5. So we can break that down into 25 and 2. The square root of 25 is 5, and 6 times 5 is 30. Okay? And then I'm just going to bring down the 5. And now can we combine those two? Nope. So that's going to be our final answer. All right, example number 9. Ooh. Now we have a binomial times a binomial. And the two ways that we talked about doing that, okay, we talked about either doing FOIL or the box method, and I'm going to do an example of both of those. Okay. So the first one we're going to do is FOIL, and that's where we multiply the first. So that would be 2 times 2, which gives you 4. The outside, so 2 times negative root 6. So it's going to be negative 2 root 6. Okay, we have to multiply the inside. So root 6 times 2, which is going to be positive 2 root 6. So the inside was positive 2 root 6. And then the last one was the last, which is root 6 times negative root 6, which gives us negative 6. Okay, so now we need to combine our like terms, which are in the middle, and those actually cancel. So now we're just left with 4 minus 6, because that's what comes down. And 4 minus 6 is negative 2. All right, number 10. Number 10, I'm going to do the box method. So we have a binomial times a binomial. It doesn't matter which one goes where, so 8 and negative root 3, and 4 and positive root 3. 4 times 8 is 32. 4 times negative root 3 is negative 4 root 3. 4 times, or 8 times root 3 is positive 8 root 3. And positive root 3 times negative root 3 is negative 3. Okay? So we would rewrite this. I'm going to combine my like terms right here in the middle. And we get 32 plus 4 root 3 minus 3. But if you look at this, we have another set of like terms. And then we get 29 plus 4 root 3. And that's your final answer. All right. So for number 11, I'm going to do FOIL. So we need to do the 7 times the 2, the 7 times the negative root 10, negative root 5 times the 2, and the negative root 5 times the negative root 10. So I'm going to leave that all for you guys, and then pause the video, and then we'll complete the next step. Okay? Good luck. Okay, so when you multiply everything out, this is what you get. The key thing is just to watch those negative signs. It's a negative times negative, so that's why that is a positive. Okay, so can we break anything down? And yes, we can break down the root 50. So this is 14 minus 7 root 10 minus 2 root 5 plus 25 into. So then our next step, we have 14 and that turns into 5 root 2. Okay, so now you can leave your answer like that, or you can rewrite it so that they're in order. So just make sure that all of the signs are the same. And there you go. All right, last one, number 12. Let's go ahead and do the box method. Oh, 2 root 3 plus root 6, 4 root 2, root 3. So inside with inside, outside with outside. So 4 times 2 gives us 8, and 2 times 3 gives us 6. 4 times 1 is 4, and 2 times 6 gives us 12. 2 times 1 is 2, and 3 times 3, well, is actually 2. It'd be root 9, which is 2 times 3, so this is actually 6. Okay? And then 3 times 6 is root 18. Okay, so we have 8 root 6 plus 4 root 12 plus 6 plus root 18. Okay, so 8 root 6 plus 4, and 12 breaks down to 4 and 3 plus 6 plus 9 and 2. Okay, so 8 root 6 plus 4 times 2 root 3 plus 6 plus 3 root 2. Okay, and now we have 8 root 6. Guys, the hardest part about this is just keeping all of your information together. Okay? Okay. So now that could be your final answer, but I'm going to write everything in order. So we got 6 plus 3 root 2 plus 8 root 3 plus 8 root 6. None of those are the same. So that's going to be our final answer. Okay? Now, if you guys need help, if you don't know anything that I was just talking about, you need to come in for extra help. Okay? This right here, oops, this is your homework, okay? Make sure it's on a separate sheet and show all of your work and circle your final answers. This is going to be what's due on Monday. Okay? Now, if you have any questions, once again, always ask Ms. Carranza or myself. We'd love to help you out. Otherwise, that's it for Algebra 1, Chapter 11.3, Notes. Thanks for watching.